Hello everyone, I hope you're doing well. Today we're going to talk about ionic bond and structure. So, our objectives today, first to define the terms ionic bonding, ionic compound and giant ionic compound, explain the properties of ionic compound and explain the giant ionic model. So, as you remember, why atom will form ion. So for sodium ion, for example, again, the proton number is 11 and the electron configuration for sodium is 2, 8, 1. So third shell or the outermost shell for sodium is not full. That means sodium atom is not stable. How this atom will be stable? By losing this electron. By losing this electron, okay, after losing this electron, the number of electron now is 10 and the electron configuration is 2, 8. The second shell or the outermost shell now is stable. That means sodium is stable now. The same story for chlorine atom. The proton number is 17, means what is the electronic configuration for chlorine? It will be 2, the maximum number of electrons in the first shell, 8 and 7. So the last shell again is not full. That means sodium has to gain extra electron, and then the electron configuration will be 2, 8, 8, and the outermost shell is full now, and the charge for sure will be -1. Now, if you look for sodium and the chlorine, sodium want to lose 1 electron in order to be stable, and the chlorine wants to gain 1 electron. So this electron will transfer from sodium to chlorine. The complete or the full transfer of electron from one atom to another, we call it the ionic bond. But this electron will always transfer from a metal atom to non-metal atom. So always the electron transfer will between metal to the non-metal. So in the ionic bond, we are talking about complete full transfer of electron from metal to non-metal element. So what is the difference between metal and non-metal? So as you know, in the periodic table, here we have a line. This line separate. So here we have this zigzag line. This line separate the periodic table into two categories. The first one are the metals and the second one are non-metals. And as you can see, 80% of the elements in the periodic table, they are metals. So in ionic bond, electrons, they will transfer from metals to non-metals. So now, after sodium lost this electron, sodium is hold positive charge, and after chlorine gained this electron, the charge is negative. And as you know from physics, when we are talking about charged particles like positive and positive, they have the same charge, they will repel. While when we are talking about particles have opposite charge like positive, negative, negative, positive, they will attract. And that's exactly what happens between sodium ion and the chlorine anion. They're gonna attract to each other because they have opposite charge. We call this force, this type of force that holds the positive and negative electrons together, the electrostatic attraction. And this force is really important because it controls the properties of ionic compound as we're gonna see. So again, when we are talking about sodium chloride, this electron will transfer from sodium to chloride, and then they have opposite charge, and then they will attract by the means of electrostatic attraction. When we are talking about ionic compounds, ionic compounds will form something called giant ionic structure. So always you're gonna see something like this, something like these crystals. We call them giant ionic structures. Why ionic compounds like only sodium and chloride, they're gonna have these structures. So again, sodium and chloride, they're gonna attract by means of electrostatic attraction. So this is the sodium atom, sorry, this is the sodium ion, and this is the chlorine anion. They're going to attract with each other. But as you know, we have millions and millions of atoms in only 1 gram of sodium chloride. And if you know, sodium chloride is the table salt, okay? So here we have sodium attract to this chloride atom, but at the same time, this sodium is attract to another chloride atom. And this chloride anion attached with another sodium ion. And this chloride is attracted to another sodium. This sodium is attracted to another chloride, and so on. So that's why these ionic compounds have this giant structure, because we have millions of atoms and the electrostatic attraction is very strong. So the electrostatic attraction for sodium and the chloride, for example, it will act in all directions, and then we're going to have these giant structures. Now we want to talk about the physical properties of ionic compound. We're going to start with the melting point. So melting point of ionic compounds, they will be very high because of the electrostatic attraction. How? Let's go back for our structure. So again, here we have this giant ionic structure. If you want to melt this crystal, so it means you want to break all this bond. You want to break them to separate sodium and chloride. So electrostatic attraction is very strong. It acts in all directions. So for sure you need a very high amount of energy in order to break all these bonds. So that's why the melting point for sodium chloride, and by the way, sodium chloride is the table salt that you use it in your home. The melting point for this molecule is around or more than 800 Celsius. The second physical properties, ionic compounds are brittle. What is the meaning of brittle? If you break this crystal, we're gonna have straight edges. Why we're gonna have straight edges? Because when this crystal is break, it will break between one row and another. So if this is the chloride and this is the sodium, they are attracted very strongly with each other. So if you want to break them, you will not break this bond, but you will break them in between the rows, so they're gonna still have straight edges, and this is the meaning of brittle. And now please solve these 2 questions. So that's it. I hope it was clear for you. Next class, we're going to talk about a second type of chemical bonding, which is the covalent bond. So what is the covalent bond? What is the difference between ionic bond and covalent bond? We're going to talk about that in the next class. Thank you and good luck.